Hi guys, welcome to Physics. I'm your instructor, Akshata, and I'm part of a wonderful nonprofit organization called KARMANT Learning. Today we are going to cover topics of introductory motion, like displacement, position, and all that stuff. So let's get started. So today we are going to talk about introductory motion. Motion is a key fundamental for a deeper understanding of physics. In basic terms, motion is described as the change of an object's position or its orientation with respect to time. Concepts related to these are called kinematics. The first thing we need to sort out are the conditions for motion. We need a fixed reference frame. So basically, a fixed reference frame is in which the observer is either at rest, meaning they are not moving, or they are moving, but they are moving at a constant velocity in the same direction. I'll go over velocity in a future video. For motion, we also need a standard set of conventions. These can be meters, seconds, or any other units. For motion, we shall describe all objects as only particles. So let's say if we have a box right here, we will draw that as a dot, which will represent it as a particle. For now, the motion that we are going to cover is only in one direction, the x direction of the coordinate axis. So as you can see, the right direction will represent the plus x direction, whereas the left direction will represent the minus x direction. The first term that we want to describe is position. Position is the location of an object relative to the origin of the coordinate axis. Recall that the origin is where the x and y positions of an object are 0. So as you can see, this object is on the coordinate axis. Its position is the distance from the origin to wherever it's located, relative to the origin. Distance is the measure of the length of an actual path that the object takes. Distance is actually a scalar quantity, meaning that it has only a magnitude, but it does not have direction. For instance, if you run a lap around your house, your distance is the length of the path that you were running. A second quantity is displacement. Displacement is the change in position. It is a precise difference between the initial and final position of an object. Unlike distance, displacement is a vector and it has both a direction and a magnitude. Let's look at a sample problem. Sally runs a lap around her square house. Her house is 20 meters wide on each side. At the end of her lap, what is her distance and what is her displacement? The edges of her house are 20 meters by 20 meters wide. We can see that distance is the total length around the house. So what we have to do is we have to find the perimeter of the house. So we would add 20 plus 20 plus 20 plus 20. And our total would be 80 meters for the distance. Now that we found the distance, we have to find the displacement. Recall that the displacement is the final position minus initial position. So here, Sally went all the way around to her house, and her initial position is shown by the dot, and her final position was the same exact thing. So here, if we subtract the final minus the initial, they are the same, so that will result in 0. If you enjoyed this video, please like and subscribe to our channel. If you have any suggestions on our content, please email info@karmantlearning.com. Thank you for watching.